Today we're going to be talking about how to solve equations with parentheses. There are a couple of ways you can approach these types of equations. One way is more reliable than the other way. So on the left side, I'm going to use the more reliable way. And on the right side, I'm going to use the easier way, but it's not going to be used in all cases. And I'll show you why. Okay, so let's start with the one to the left. On this one, I'm going to be using the distributive property. Now, what is the distributive property? Well, if you missed my previous video, it's simply multiplying the number outside the parentheses, which is usually called a coefficient, with both terms inside of the parentheses. So here I'm going to multiply the 3 with the 5x, and I'm also going to multiply the 3 with a 2. Okay, so 3 times 5x, I'm going to go ahead and write it. All right, and then bring down the operation, the plus, the addition, and then 3 times 2 over here. Now, in the next example, I am not going to show the actual multiplication part. I'm just simply going to show the result, but I'm simply doing this for as a start, so you guys see the breakdown of the process. Okay, so 3 times 5x, you multiply the number, the coefficient in front, with the coefficient of this variable. So 3 times 5 will give us the 15x. All right, plus the 3 times the constant 2 will give us the 6, equal to 66. So this process, using the distributive property, we were able to get rid of the parentheses by multiplying the coefficient outside with both terms inside of the parentheses, giving us the 15x plus 6. Now we can solve this just like any regular two-step equation where we subtract 6 on both sides. Now the reason why you want to subtract 6 is because 6 is a constant, 66 is a constant, and you at the end you want to isolate the variable, the x, so you start moving terms away from the x term to the other side. Okay, so I subtracted 6, the 6 that's adding and the 6 that's subtracting cancel out because they are opposite, and the 66 minus 6 will give us 60. I'm going to bring down the 15x right next to the equal sign. And now, to get rid of the 15, the coefficient of x, remember they are multiplying, so the opposite of multiplication is division. So I'm going to divide both sides by 15. On one side, 15 divided by 15 gives us a whole, so 1 times x, or simply just x, equal to 60 divided by 15 will give us the answer, which is 4. All right, so here we solve for x by using the distributive property, and then eventually we isolated the x, leaving the x alone by moving terms one by one to the other side until you get to the answer of x. Now on this side, we're going to use a slightly different approach. Now, this approach is useful when you know that the coefficient in front of the parentheses is going to be able to divide the total, in this case, the 66. So 3 is a factor of 66, so I know I can simplify the 3 right away. So I'm not going to bother using the distributive property here, multiplying both terms. What I'm going to do instead is I'm going to do a long fraction line, and I'm going to divide this entire expression by 3. And whatever you do to one side, you have to do to the other side of the equation. So I'm going to divide this side by 3. Now, what this will do is the 3 that's dividing will eliminate the 3 that's multiplying. And here's why. When you multiply by 3, 3 times 5 will give you the 15x, but then you get divided by 3 again. So then the 15x gives you back the 5x. 3 times 2 gives you the 6, but then the 6 divided by 3 gives you back the 2. So literally, this 3 that multiplies will make these two terms 3 times greater, but then the 3 that divides will make them 3 times smaller again, so giving back the same result. So anytime you have a coefficient that's multiplying, you can divide by the coefficient, in this case canceling into a whole, leaving you with the expression all alone without the 3 in front. So it's 5x plus 2 equal to, And then 66 divided by 3 will give us 22. All right, so this way we were able to remove the 3 in front of the parentheses, and as soon as the 3 is gone, there is no need to keep that parentheses around, so I removed it here, leaving you with just the expression inside of the parentheses. Now I'm going to do a similar move like I did over here. You want to move the 2 where the 22 is, because they're both constants and you know they're going to combine. Since the 2 it's adding, I'm going to use the subtraction property of equality. I subtract both sides by 2, eliminating the 2 that's adding, combining its opposite value with the 22, giving you the 20. Bring down the 5x, and here I'm going to divide both of them by 5 because the coefficient was 5, and you always divide by the coefficient, similarly to what we did over here to get rid of the 3 in front of parentheses. Now x equal to, of course, is going to be the same answer, 4. Now some people prefer this method because it tends to simplify things quicker than using the distributive property, because with that you're multiplying, getting larger numbers, and then having to deal with large numbers. Unfortunately, this approach is not always it's not always going to come in handy, and I will show you an example next that this approach will not work right away. So that's that. Let's move on to our next slide. And here's the situation where using the division of the coefficient, in this case the 5, will not work. Now if you want to give this a try on your own, feel free to pause, try and attempt it, solve for b here. All right, so as I said before, dividing this by 5 is not going to be doable. First of all, 7 divided by 5, it's not going to give you a whole number, but also when you divide, you have to divide every term, not just on one side, but every term on both sides. Okay, so here if you divide by that 5, you got to divide the b by 5. This of course will cancel, so this will work, and this will give you a decimal, so this is not going to be a good situation. So instead of dividing by 5 here, what I'm going to do is I'm going to use the distributive property. Okay, and I'm only going to focus on the where I see the parentheses here. So here I'm going to multiply by 5 the b and by 5 the 1. Now before I do the multiplication, because the b is not going to be touched, I am simply going to bring down the b and the addition in this case, because 5 times b will give me positive 5b. Now 5 times 1 will give me 5, and because this is a subtraction, I'm going to keep it as subtraction. So subtraction by 5 equal to 7. All right. So now we use the distributive property, got rid of the parentheses. Now you have a couple of options. You can combine the like terms here, getting the answer here, or you can move over the 5 to where the 7 is. Either way works. So what I'm going to do first is I'm going to move over the 5 to where the 7 is. To do that, since the 5 is subtracting, I'm going to add it to both sides. This is known as the addition property of equality, of course. You add to both sides to keep the equation equal. Bring down the equal sign exactly in the same straight line, so you can use the dotted line to help you, remind you where the equal line is. All right, now 7 plus 5 will give us the 12 here. The 5 and the 5 cancel because they are opposites. Now here you could rewrite b plus 5b, but because I know they are like terms and b has a coefficient of 1, I simply just add the coefficients, giving me 6b here. All right, anytime you have a variable without a coefficient, you can always put a 1 when you're combining like terms, just to remind yourself. If you're good at remembering that, then just simply add b with 5b, giving you 6b. Again, we got to get rid of the coefficient. And since it's multiplying, you got to divide by that, because our goal in the end is to isolate the variable, leave the variable all alone. Equal to 12 divided by 6 will give us the 2. All right. Now, as you can see, pretty much anytime you solve an equation, what you're doing is you're leaving the algebraic terms on one side and you're moving the constant terms on the other side. And eventually, when everything gets simplified, you will end up with a variable equal to its value. All right. So this was the example that we can only use the distributive property, and dividing by the coefficient was not possible because of this b over here. Let me show you a case now where you could go either way, where you could do the division by the coefficient or use the distributive. However, you have to do one move beforehand. So let's move on to our next page. Now, looking at this example, you'll notice that here you have a plus 3. Now, if you wanted to divide, actually, if you want to give this a try, pause, go ahead. All right, now, because of this plus 3, you cannot start dividing right away by 5, all right? Because if you try to do that, you then have to divide the 3 by 5 and the 48 by 5, and unfortunately, neither the 3 nor the 48 will give you whole values, so you'll get a decimal answer. So, division by 5 right away here is not possible. I'm going to go ahead and erase that. So anytime you see numbers that are like terms like the 3 and the 48, they are both constants. You can actually combine them. Unfortunately, because they're on opposite sides of the equation, you can't just add them. In this case, you got to do the additive inverse of 3, which is subtraction by 3 to both sides. This one would cancel the 3's here, and then this one would give you 45. All right, now here, I'm gonna go ahead and actually, why don't we use the distributive property and write the answer below? So then 5 times 2y will give us 10y. And then 5 times 7 will give us 35. Now, because 5 was positive and this is a subtraction, the operation will be subtraction. All right. Now here you've got the variable term, 10y minus 35 equal to 45. Now, of course, 35 and 45 are both constants, and this 35 is subtracting. So if I want to move it over, I need to add it. And the reason why I want to move over the 35 is so that I can isolate the 10y. I want to leave the y eventually all alone. So here I'm going to add 35 on both sides. Okay, this one will cancel, leaving us with the 10y on this side equal to 45 plus 35 will give me 80. And then to isolate the y totally, I'm going to divide by its coefficient, the 10 here. And then that would give me y equal to 8. But I also said that you could solve this by dividing by the coefficient. However, not right away. So real quickly here, over here, what I'm going to do is I'm going to rewrite the equation. And I'm going to show you how you could divide by the coefficient of 5. So we got that. All right. Now you have to move the 3 because the 3 is not divisible by 5. So we have to subtract it. All right. So the first step is identical in this case. Canceling the 3's, giving you the 45 here. Now here I'm going to bring down the entire expression as is with the parentheses. 5 parentheses 2y minus 7. Now, instead of using the distributive property to get this, what I'm going to do is, since now the 5 and 45 are 5 can divide 45, I'm going to divide this entire expression by 5. And whatever you do to one side, you have to do to the other side to keep the equation balanced. Equal 45 divided by 5 will give me 9. Now the 5 that multiplies the parentheses and the 5 that's dividing will cancel out eventually, leaving you with the exact expression inside the parentheses, 2y minus 7. Now we no longer need the parentheses because there's no number outside of it. So that's pretty much got rid of the parentheses here and the 5. Okay, last two steps. I got -7. I got to move it over. So I add 7 to both sides. All right, bring down the 2y. The 7's cancel here. Bring down the equal sign. And then I add 9 plus 7. That will give me 16. Final step, divide by the coefficient. In this case, the coefficient is a 2. Leaving me with y equal to 8. All right, as you can see, I got the same answer here. Now, this method, again, was used. However, you had to do it after the 3. From personal experience, using the distributive property tends to be a little easier. Even though you end up getting larger terms, it's a little easier to do, especially when you're first getting started, because it can be used at all times. All right. Whereas the dividing by the coefficient in front of parentheses, it's only capable, you're only going to be able to use it at certain times when you know things are all going to be divisible by the 5. Like in this case, the 5 and the 45 were both divisible by 5. All right. And to prove the point that distributive property is more useful, I'm going to show you our last scenario. Here is a pretty long equation. I would say when it comes to distributive property with whole number coefficients, this probably would be one of the most challenging ones. I would say this in the US would be 8th grade level type of equation. All right, so in this case, you can see that you have a 9 coefficient in front of this parenthesis and you have a 2 coefficient in front of this parenthesis. Now, right away, you'll know that if you try to divide this, you have 2 different numbers multiplying, so dividing 9 by 9 would work, but 2 is not divisible by 9, and then 157 is not going to necessarily be divisible by 9. It might, I don't think so. And then if you try to divide by 2, you're going to run into the same scenario. 9 divided by 2 is going to give you a decimal. Same thing when you try to divide 157 by 2, it's going to give you a decimal. So instead of dividing by the coefficient, we're simply going to use the distributive property on all of them. And what I mean by all of them, I mean the 9 will multiply the 7h, and the 9 multiplies the 3 here. I'm going to write the answer below, and then the 2 here will multiply the 3h as well as the 8. All right, and then 157 will come down. Now let's start with 9 times 7h. That's going to give me 63h. Plus, everything is positive, so bring down the plus. And then I'm going to do 9 times the 3, which is going to give me 27. So far, so good. Now, this part, it's a little tricky, and here's why. The 2 has a subtraction sign in front. Now, that subtraction is going to behave as a negative value when you multiply with a 2 here. So you're not technically going to multiply with a positive 2. You're multiplying with a negative 2. Now, negative 2 times 3 will give you a negative 6. And that's going to be an h term. So negative 6h. Now, the second part is the tricky one because most people will just bring down the subtraction. However, because this is a negative 2 multiplying the 8. Now, there's 2 ways you could think of this. You can think of the 8 as a positive. Multiplying a negative with a positive will give you a negative 16. But then you have a subtraction, which gives you a double minus, which will turn everything to positive. So that's confusing. So instead of thinking of this as a subtraction, you can think of this as a negative. Think of this as multiplying a negative with a negative. So you got to practice with this part to kind of understand a little better. So anytime you have a subtraction and you're multiplying things with it, think of that subtraction as a negative for the term that's behind it. So in this case, it will be negative 2 times negative 8, giving us a positive 16. And again, because a negative times a negative turns positive, equal to the 157 didn't do anything to that, so I'm going to bring that down. Now, another thing that makes this equation a little challenging now, and that's going to be true for pretty much all equations with a lot of terms, is that you have a bunch of like terms that you got to deal with. Now, using the balancing method would not make sense in this case, because you cannot do the opposite operations on the same side of the equation. You got to treat this as an expression, because it is an expression. So what I mean by that, oops, I just noticed here I wrote 63b. I meant to write it as h. So let me go ahead and fix that. All right, so that's 63h, not b. All right, so now we're going to start combining like terms. Now, how can we do that? Well, one way that I do this, you can move the like terms together, but I'm going to skip that step. What I do is I usually put a little circle around them. Now, what I make sure to do is I make sure to circle, let's use a different color here, to circle the operation in front of the terms. So the 27 has a plus, and then the 6h has the subtraction. So I'm going to think of that as a negative, and then going back to the 16, that also has a plus. Now, the reason why I use the yellow for these two is because they're both constants, and red because both of them are algebraic terms and they both have h's, so they are like terms. So what I'm going to do here is I'm going to bring down the h term and I'm going to combine them. Now, when you combine them, it's not going to be 63h plus 6h. It's actually going to be 63h minus 6h. You're going to use the minus, the subtraction here, instead of the addition, because the addition belongs to the 27. All right, so it's 63h minus 6h. That's how you know whether you got to add or subtract. You look at the sign in front of the term to do the operation. All right, so 63h minus 6h is going to give us 57h. All right, and then over here, I'm going to color code that too. 27 plus 16, it's going to give us 43. All right, and because they were both positive, I didn't need to subtract anything. I added them. All right, hopefully this is visible. And then I'm going to bring down the equal 157. All right, now last couple of steps. Here you've got 43, and because it's a constant, you can combine it with 157. So you have to do the 57h last. So since the 43 is adding, I'm going to go ahead and subtract 43 to both sides of this equation. All right, I'm going to bring down the 57h. Now, the reason why I brought it down over here is because I know the 43s are canceling because they are opposites, bringing down the equal sign, and 157 minus 43 is going to give us 114. All right, and then I'm going to divide both sides by 57, the coefficient, of course. So you always divide by the coefficient, unless it's a fraction, but I will show that to you in another video. So here the coefficient is multiplying the h, so you divide by 57. Whatever you do to one side, you do to the other side, leaving us with h here because the 57s turn into 1h, or simply h, equal to 114 divided by 57. Luckily for us, is exactly a 2. All right. Now, you will not always get whole numbers as the answer. Sometimes you will get a decimal. Now, if you want to make sure that you have the right answer, there is what's called a check. However, I'm not going to be doing that in this video. I'm going to be doing that in another video, how to check that you have the right answer. So for now, this is it. If you enjoyed the video, please make sure to like and subscribe, and please comment on any suggestions or anything that you think I can use to improve the video. Thank you so much and have a good day.